Edokwa ụmụaka na-achọ mkpọtụ. Hello, everyone. We are live today from Ikeja in Lagos State. I told you, we are coming to a city close to you. So today we are live in Ikeja in Lagos State. Sorry, we had to move this meeting forward by almost 4 hours. I drove over 6 hours from Onitsha to Lagos. So we got here just about when I was supposed to start. So I needed to, rest for a while. Sorry about that though. So I can see Abib from Lagos. Yes, Abib, I'm in your state. And Musa Bala Shehu from Kano State. Yusuf. Hello, Yusuf. Adam Mutala Muhammad from Kano. Abdul Aziz. Yes. Buhari Bila from Kano, Katsina State. Muhammad Bukar, Borno State. Yeah, Zainab. I missed that. Okay. Eric said, welcome to Lagos. Thank you, Eric. From River State, Francis Egeha from River State. Usman Ali Castina. Mustafa from Gombe. Not sure what's going on. Okay, 1 minute, please. Yeah, I lost my feed on this. Okay, video link is here. 1 minute. Okay, 1 minute, please. Okay, I think we are fine. So, yes, I see you guys from Oyo State, Ismail Lawal, Amos Samuel, Oyo State, right? Eze Shema Shinyere, Abigail Ina from Calabar, Amina Raji, hello. Aminu Garba from, I missed that. Usman from Duse. Kevin Olusobu from Lagos State. Okay. Lawan from Yobe State. Helia Ibeyom, Adamawa State. Eunice, scrolling so fast. Abdullah Lawal from Zamfara State. Something Ushe from Plateau State. I see Kaduna here too. Emmanuel Abaje Kaduna. Joseph Abi, Cross River. Yeah, I've not seen Cross River in a while. Good to see from Cross River. Sokoto State. Nicholas Adamo from Sokoto State. Gombe, I see you. Tilde from Gombe. 1 more minute and we dive into what we have for today. So in the next 1 minute, that's 5 minutes after 8, we'll dive in. I see Imo State, Samuel Osuji, Imo State. I see Adamawa State, Ahmed Balango from Adamawa State. Borno, Fatima from Borno. Aisha Baba from Bauchi State. Lawan from Bauchi State. Adam Aliu from Kano. Hamid Adam from Kano. Okay, that's it. So let me share, as usual, let me share my entire screen. So when I switch between the presentation and my code editor. We won't have Slack on that. So I'm gonna stop sharing now and share my entire screen. 1 minute, please. Stop share. Okay, and new. Sharing my desktop now. Okay, here we go. And that's okay. Well, welcome to Introduction to Golang Part 2. A bit of announcement, please. So we've been having questions about the assessment. Some people say, we've not seen the assessment. Our progress is not showing. Yes. Now, your progress will show when you do the assessment. But assessments are not available because they are locked. It's only when the assessments are unlocked, you can do the assessment. And as you do each assessment, your progress will show, because that's the main thing that shows, the assessment that shows your progress, okay? Now, we should know that it's a holiday season. Almost all over the world, it's a holiday season. So our back-end support from Fifth Work, they are on holiday. So we couldn't get confirmation on the exact, we're hoping it has to be today, but they are still on holiday, which is the normal thing. Only that over here, we are trying to, because we know majority of people in this program don't have tech background, don't have computer programming background, and they want to become blockchain developers. So we are making extra effort on our own, to have these classes going just to help you guys to move to the next phase. I want everybody in this course. In fact, on our Telegram group, we are over, I'm not sure the figure, but I know we're over 40,000 on our Telegram group. So I want every single person in that Telegram group to move into the next stage. And that's why we are doing this. So we are live today. We're going to be live tomorrow. We're going to be live the day after. And today, someone from the BSV ecosystem, one of the companies in BSV ecosystem, reached out to us. They want to, be part of this program. So on the 31st, we might have another session, but we're going to show you the kind of projects that's in the BSV ecosystem and what they do, just to guide you, it's good to see your finished product. Look at where you're going. Look at people that are there already. So we might be having guest speakers from Germany on the 31st. Just a heads up I'm giving. We'll arrange that and fix that, okay? So I'm saying I want every single person that applied for this scholarship to move into the next phase where you actually learn how to program, become a blockchain developer. And that's why we are having this live session going. It's holiday. I drove 6 hours today, but as I said, this class is gonna hold, right? And here we are holding, no matter where we are, as long as it's time, we want to come in and have your boss. So please make use of opportunity. Again, some people have not even logged on to Fifth Work. So we set up about 93,000 people on Fifth Work. That's what we set up. Majority have not logged on. I don't know why. Where we send out new emails again to the people that we notice have not logged in. Please, if you got our email that you have logged in and you are doing your course, ignore. But we looked at the data. So we send out email to lots of people that, or their portal is showing no activity. They've not logged on. If you're one of them, you can still make this, okay? The major criteria for moving to the next stage is this introduction to Bitcoin theory, which you are doing on Fifth Work. Complete it, read everything. Once the assessment comes up, it's quite easy. It's not something out of the moon. We're not getting extra material from anywhere. The assessment is based on what you read, and each section, you read each section, you see the assessment. Assessment will be section by section, right? So it's something you can pull up the assessment. On another tab, you have the section on, if there's something confusing, you can look it up again. Important thing is understand it. These days, we're interested in get the job done, not the certification. Oh, I got, no. Understand it, know it. So the assessment, they are not timed. You take your time, go through them and complete them. So if you haven't logged on, please, you still have time. Course is running until 1st. If you're diligent enough, you can finish in a single day, okay? I want to see everybody in the second phase. Okay, let's get down to the business of today. Introduction to Golang. We've done the part 1, where we introduced this and, talked about both the data types and, stuff like that. So today we are continuing here. Intentionally, I try to finish JavaScript before coming back, because JavaScript is a way more simpler thing than Golang. But what we are doing in Golang, you'll see that we already done them in JavaScript, so it won't be new to you. If you attended the JavaScript class, relax, you're fine. The only thing that might differ is the syntax. The way they do in JavaScript might not be the way they do in Golang. So what you're going to learn now, for each topic we look at, find out, okay, this is how they do it in Golang, okay? I already know how they do it in JavaScript. Super excellent. Now, this is how they do it in Golang. So that's the approach we'll do. Because this is the second part, we've done a lot before. I just want to dive into some codes. We've been coding already, so let's take a look. Now, in Golang, every program you write in Golang must have the package main. It's important. It's a package. Remember, a package, series of libraries that are, connected, related to each other. You put them into a package. So we have the main. It's a package, okay? So you must have to state that package main. Remember again, I said this several times. Programming is not like you need to solve some powerful math to understand something. No, somebody sat down, haven't looked at C language, because if as we go on, you see that there's more similarity between Go and C language. They are very similar somehow. There are some places they have differences, but the majority they are similar. So as we go on, you will see these similarities. But the thing is, somebody sat down, looked at C language, looked at JavaScript, look at all this language, look at the normal standard in programs. So, okay, in my own case, this is how you're going to do this. Okay, look at the function on our screen. We say function main. Under that function, we have fmt.printf. That printf, that's what we are seeing in Go. Remember, in JavaScript, what we have is, okay, yeah, you still have that. Okay, you can still, you have console.log. Maybe you're doing some debugging. So that guy says, if you want to, send something to the screen, use console.log. So that's what we mean. You learn each language, but generally it's the same thing. You still meet all the types of data we've talked about before. So you have that package main, then you import. Now, import is another package, something a module written by, although this is part of Go module, the FMT, the format module. It's through this format you can get things like print, and interact with your IOs, input, output. Okay, so that's why inside the main function we have func main. That func means, hey, this is a function we are trying to declare, and the name of the function here is main. Every Go language must have a main to run, just like in C. If you're used to C, you know that you can have your prototypes, you can have all your functions, fine, you define all of them, great. But it's only if you don't have main, that program will not run. So when you say main, is the entry point. So when you want to run this, is first go to main. All right, where is my main? Here it exists. If main doesn't exist, we throw error for you. So we now say fmt, which is a format, dot. Format has a method called printf, and we say hello world. That backslash n means new line. After writing this, move the carriage to the new line. That's all it means. So, okay. So this is a very simple program. If you've done JavaScript before, it looks familiar, kind of. Only that we are not having console.log. Then we're having printf. Okay, let's just go into our terminal and take a look at this. We'll come back again to the slide. Okay. Yeah, 1 minute. Let me go to NITDA. Yeah, NITDA Blockchain Scholarship, Golang. So when I'm done, I'll be committing this code as soon as I'm done. Once I commit it, everything goes up. I'll delete everything I have on Golang before, just so we start all over again. So where am I? PWD, print working directly. Okay, I'm in Go. So I just go back one level. Aha. Let me zoom in on my screen, please. 1 minute. Just so you can see. The last time the complaint is too tiny. So Control plus, Command plus rather, Command plus. All right. Let me increase this. Okay, better. I clear my screen. Okay, here we are. So PWD, where am I? I'm inside Golang. So I'll step back one bit. What do I have here? I have greetings and hello. So I'm removing them. Remove. Don't worry. Normally, what you could do is you go to your file manager here and you select whatever it is and say delete. Okay. But if you are already used to the terminal, it's way easier to just give the commands and everything works out. So I want to remove greetings, like I want to delete greetings and hello. There are folders I created before. Oh, if you complain, it's folder. So I use it /R, do that recursively. Here we go. Okay, it's empty. So we've installed Go. In the first lecture, I showed how to install Go. I got a lot of complaints from people. Okay, no, I think it's more of VS Code. Not much complaint from Go anyway. So again, if you install Go, the way it works in Linux and Mac is from your command line, you access it and give all your commands, okay? I know Windows has CMD. Yeah, it has CMD, and this, not just CMD, it has this later one. Sorry if I remember the name, the command, but more robust than the CMD command, okay? All right, so here I want to make a directory called hello. Now, in Go, remember, it's compiled. So we told you you could set up your modules, okay? But what we are doing, we're just doing some simple things. We are not creating complex stuff, just for instructional purpose. So we keep it very simple. We'll just make a folder for each program you want to run. Inside that folder, you now create your files inside it. So I want to create a folder called hello. So it's just a folder, right? LS is there. So inside this folder, I'll create a file and we call it hello.go. Let me use Explorer to do that for people that uses Explorer. So I'll click here. This is my Explorer. I want to go down to Go. No, NITDA Blockchain Scholarship. See, Go. I have gone that Go. I have hello. So this one here means new file. See, I click the new file. What's the file name? We call it hello. Oops. Hello.go. Enter. On this part, it opens. All right. Okay. So we start. Package. Main. That's the first thing we put. Then we want to import other modules. So import, since we are importing only one, we'll just put it on the same line. FMT, the format. Yeah. If you see, it's still telling me it ruled it. Why did it rule it here? Remember, I'm using VS Code, and it gives you a hint. Nothing wrong here, just saying we are not done. You haven't seen main. So you say, hey, something's not complete. So let's go ahead and put our main and see what happens here. 1 minute, please. Yeah. Okay. So I'm back to my. So we just call it func main. And we enclose everything in a curly braces. So that's the body of the main. And I have 1 minute. I'm surprised why these guys stay marked here. It removed it. And why? Anyway, let me go ahead. So I have it removed the FMT. Oh, I know why I removed it. I never called it. I'm sure. I hope that's the reason why I removed the FMT, but let's see. We import FMT format, right? So I now say FMT dot. Ah, I see. I'll tell you why in a bit. Print F. And here we say, hello world. That. So just in case, if you're writing this code and you encounter what I just did, I have formats here. When I saved it, it deleted the import format. Let me tell you what happened. Because VS Code, it already has, it knows I'm using Go, okay? It knows the syntax for Go and everything. So I imported format, but I never called format anywhere. That's why before there was something rude on that format. But the moment I put format here, it stayed. So it's not going anywhere. I need a new line character. So this N, okay, Control S, I've saved it. So here I can just say go run. Make sure you're in the directory. Let me see where am I. PWD means print working directory. Yeah, I'm inside my Golang. Let me check the file I have there. LS list the files I have here. No, this is a folder, so I need to go into the folder hello. CD hello. Let's print my working directory again. Yeah, I'm inside hello. LS, let's see the file inside hello. Hello.go is there. So I'm in the directory. So when you create your directory, right, you have to go into that directory. That's where you create your file. So if you're giving a command, make sure you're giving it from the right place. If I'm outside of this hello and give you a command, except I stay the path, which you can still do, but just go into that directory and you can give your command. So I can say go run hello.go. Yeah, let me clear the screen and do it again. Let's collapse this one. I clear my screen. So let's run that again. I say go run hello.go. Now see how I type HE, put the tab key, it completed it for me. That's one way you know you are at the right place. Sometimes you navigate into a directory. If you're using command prompt, just type part of the name and hit the tab. If it doesn't auto-complete it, either you have similar names, okay? But if not, it means you're in the wrong place. So one way to know that, oh, I'm in the wrong place, and I'll check it out. So I say go run hello.go. Let's see. And look at that. Hello world. That's it. So we just run our first program under the Go. Okay. Remember, I just did install. I didn't call up, I didn't go to application, call Go. No. It does just install your Go, then go to your command line, command, wherever. If you're using Mac and Linux, you have your terminal. If you're using Windows, you have the CMD, but no, there's one more. Sorry, I remember the man I said, but it's a better tool than the CMD, right? Okay, so that's it for this. Let me get back to my slide. We just run our first program. It say hello world and took us to another line. If I remove this line, look at what happens. If I remove this \n, it will run. But let's see. Let me run that command again. Go run that. You see how I say hello world on the same line, it gave me my command prompt. So that's the essence of putting this \n. It just means new line. After running this command, please send the carriage to a new line. Hit a return. It's like saying enter. If I run this again, Control S start. If I run this again, hello world, and it does a new line character. Okay. So that's it. So here's another example. In this case, what am I trying to do here? Okay, yeah, with the JavaScript we've done already, this will be pretty good. So I'm kind of like, I'm assuming you have programming experience. Remember, we did JavaScript. So we do this, we now get back to try to define everything that is in this program, okay? So don't worry, just follow through. I will explain it as I go on, but if it's confusing to you, don't worry about it. You understand it. We'll still have to go through all the definitions in the later slides. So here's another example. We have a package main. We have the import FMT, the format string. For now, that's all we need. And here we say func, hello. So the function name is hello. In the JavaScript, we describe what a function looks like. So in Golang, you define that you are writing a function with the keyword func, F-U-N-C. It means I will try to write a function. Remember, Golang is a functional programming, so it's all about functions and functions, although they are struct, where you have to describe your own data types and methods, okay, using the struct, but it's more about functions, everything functions. That's a functional programming. Okay, func, the name is hello, right? And this, it takes a string. It takes a string called name. So it takes it takes what we call a parameter. We wrote name here, but it's just to tell us, put a name, you know, a placeholder. That's what it is. In actual sense, when you are running anything you pass there, as long as that is a string, it will work. If you pass an integer, it will not work, because you tell him this function accept one string, only one parameter, and that parameter has to be a string. Then this string here means return a string. When you finish running, return a string for me. So the return value for this must be a string. If you try to return something that's not a string, it will throw error. I saw this when I started doing Golang, when I started it way back. So I run things, I tell me return, you know, it was confusing, but for you, I'm just showing you, it don't have to be confusing for you. It's a function. So func, hello, that's a name. That's how you call it. And it takes only one parameter. Okay, and that parameter is a string. It doesn't matter what you call this. You can call it name, you can call it Bob, you can call it X, Y, whatever you bet. The important thing is that it has to be a string. And this string here means when you are done, return a string. Okay. Then inside the curly braces, which is the block, the body of the message, we now say, hey, message column equal. I'm not sure if I explained this column equal. Okay, let me get back to the terminal just so we could see that. Let me explain this. So let's make a new folder. So we are done with hello world, okay? I leave it the way it is. I go here back to Explorer. Let's use Explorer again. So under Golang, not under hello, so I zoom out of Golang. So under Golang, you see I'm on Golang, it's highlighted. I'll click new folder. Look at it. New folder. I'll give it a name. Let's call it greetings. Okay, it's just a folder. So inside this folder, let's make a file called greetings.go. So I make a new file. This one for new file. See that new file? I hit that. I call it greetings.go. Aha, of course, he marked it red, like, yes, there's error. I mean, we've not done anything, it's understandable. We'll start putting the function. So before I do this, let me explain. So let's say you say, I have that variable X equals, no, let's declare a variable, call it X, and it has to be an integer. This is a declaration, you know how to declare a variable. So I just declared a variable X. I call this a variable called X. That's an integer, okay? Now let's assign some. We'll now say X equals 5, for example. So what we did here, we first declared a variable called int. It's legal, it's fine. When you declare it, it just gives it a null value automatically because you didn't declare anything yet. So by default, it will be null, okay? I think integer is 0 in C. I might check. Okay, but no value yet. In the second line, we now say X equals 5. So we assign value to X. And say this container called X, store 5 in it. We can do this in one line. We can say variable X int equals 4, for example. is valid. So what we did, we declared the variable x, call it an int, and assigned it value. Now Go has a special syntax. It's just in Go I've seen this syntax. Rather than go all through all these variable s, int, it has a shorthand method. And the shorthand method, you can say that x column equals 5. So what this does, it says that it declares a variable called x, and in this variable, it assigns 5 to it. Yeah. So yeah, variable, you didn't even say the type, but just seeing 5. Go is intelligent enough to know that 5 is an integer. So it assigns integer 5 to x. Now it's a shorthand. You see this a lot when you are doing Go Pro. So when you see x column equal anything, it means you are declaring a variable and assigning it at the same time. Initialize that. So you declare the variable and you initialize the variable in one single line. So it's a shorthand method of writing out this line 3. Okay, so you see that a lot in the program. Fine, that clears that up. Let me come back to the slide. So that's what we have. We say message column equal. So we declared a message and we're applying something to it. And what is that? We said format.sprint. Sprint is another function under FMT. Okay, and you say hi %v welcome, comma name. So this %v here is a place. So you say, well, if a data type is saying there's a, this string here, there's something, a value here, %v, but what's going to be inside that %v is the name. So it's like a substitution. You substitute it with some other thing. %v tells you what kind of data type, what kind of data type is expecting to be here. And here is expecting name to go in there. Now look at this, we say return message. So remember what we said. This function, we say this function return string. Now, message you can see is a string. Look at that, it's under double quote, so it's a string, right? So when you run this, it will return whatever is here. And we now call another function. Don't worry, it's not too complex. This is the main, this is where I started running. This function, hello, just on its own, yes, it does something, but it's only when you call it in the main, you can actually interact with it. So that's why in the main now, we now say printf, what are we printing? Hello is a function. That's how to call a function. And we pass a value. Remember, we said this function can take only one value that's a string. So when we call hello, we pass Callistus to hello. And if we run this program, let's see what we'll do. So let me just go ahead and type it out. And blah, 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 blah. Okay. So I'll get rid of all this. Remember, we declare our package main. There we go. And then we import FMT format, right? We go to the next line. We now declare our func. What is the name function name again? 1 minute. Okay, function hello. That's what we're declaring. So function hello. Yeah. It takes a name, but this name is a string. You can see the color coding. It tells you you're right. If you see the string turns to green, hello is somehow yellow, so we are fine. And what does it return? It returns a string, right? Yes. Then we put our body, whatever have to go into the body. And what do we have again? Yeah. Okay, message. We want to print hi, placeholder, welcome. That's what I want to print. And we're using the shorthand method here. So we say fmt dot sprint. Is it sprintf? 1 minute. Yeah, sprintf. Now, we'll declare our variable first. So let's start all over here. So we declare a variable called message. And we use the shorthand method to assign something to it. Equals, here we have a fmt dot s print f. And what are we printing? We are printing hi percent v. That's the placeholder. Again, see how percent v turned to some other color. Once you put percent v in it, we're on track. Hi, what was the other greetings we have? 1 minute. Okay, hi, welcome. That's what we have. Let's say full stop after hi, then welcome. So, hi, then welcome with exclamation mark. So that's the string. Everything under that double quote is the string. But you see, we put a substitution, %v, we want to substitute something into it. So you separate that with a comma. That's how it's done. You now put whatever substitution you want. In this case, we want to put name. Whatever the name is what we want to put there. And remember, when the person calls, the person passes a name into this program. Look at it here. I say, function hello. Whatever you're calling this function, put a name, and that name must be a string. Okay? So that's what literally we've done here. So message that. So what do we want our code to do? We want it to return. Look at this. Message is highlighted in red, like error. Do you know why? We declared message, but we have not consumed message. That's what that means. The moment we consume the message, you know, it gets used to somewhere. That error goes away. That code hint goes away. So we say return. We want to return message. You see, now I say return message. That error has gone away. Means, hey, we are fine. Now we just defined a function. It does something, but this function, if I run this program, it won't even run if we throw error because there's no main. Let's try it. Let me try to run this. We've done a function, right? So, and what's the file name? We call this greetings.go. So I'll go into the greetings folder right now, pwd. I'm in the hello folder. So I'll go back one level up. ls, I have greetings. So I was changing to greetings. So I'm into greetings now. ls, confirm. Yes, I have a greetings.go. So if I say go run, greetings.go. Yeah, you say, it said runtime main. It called main twice. Function main undeclared in the main package, whatever it is, you know. So main is not there. Couldn't find the entry points. We know there will be error. So let's go now and create our main. Main is the entry point to your, if you are doing C or Go, it's from the main that your code executes. The entry point is your main. So we come back here, we put our main function, func main. It doesn't take any value, just void. It doesn't take anything, but it prints something in our case. So here we say fmt dot print f, right? And what is it going to print? Hello. Yeah, it's going to print hello for us. Hello is a function. You can see the function is showing up here. I select that. And this function requires a value. Now look what the hint says. Say, hello, name string. So you have to pass a string. You know, we call that string a name. It's giving us a hint what to do next. And you know why? Because you declared, you say this function takes a string you call name and it has to return a string. So in this case, I pass a string. To pass a string, put double quotes. So Callistus. Yeah, every error seemed to have gone away. Okay. So what we did here, we said we called this hello and passed Callistus. So what will happen? It will go and look for hello. It sees hello here. And the value we gave it is Callistus, right? So when it comes to name, here we have substitution. It will replace this thing with whatever name we pass. So that's how this works. Did we put a new line there? Yeah. So I'll put a new line here. Okay, I save that. We go back to go run. Go run. This time around, we are running greetings.go. Hi, Callistus. You see that? So we said, why not welcome? What happened to welcome? 1 minute, please. Hi, Callistus. Welcome. It didn't print welcome. Why? Let me see. You just say hi, Callistus. Let's see my code. Everything seems fine here. Okay. Let me get back to that. See. We actually told you to print that. Why didn't you print that? Hi, person B, welcome. Yeah. Let me run that again. Oh, there's welcome there, but it's another line. Look at that. Hi, Callistus, welcome. I didn't see very well. Okay. Yeah. Look at what happened. My fault. So I said, once you print Callistus, go to the new line. It was my fault, actually. That is doing what I say it should do. So you printed Callistus and went to the new line. So this new line is out of order, please. Shouldn't be there, right? I rather put new line here after welcome /n. Yes. So let's run that again. Hi, Callistus, welcome, one single line. So I introduce this error. And again, when you run a program, it doesn't come out the way you want. You have to, why didn't it come out? You take a look at it. So I actually say, after Callistus, go to the next line, and that's what it did. But I wasn't looking at the next line again, because I thought it's just this, but yeah, we are fine. So we got it all right. I've saved this, so we'll be fine. So we just gone through 2 different programs in Go, yeah, and we see how it works. Simple. Okay, let's get to the main meat of Go, other stuff in Go. Pointers, a very important subject. So what is a pointer? A pointer stores a memory address of other variables. This is one place that C excels. C, you use pointer to manage the memory by yourself. Remember we say Go manages memory for you. If you're doing C, for example, as far as your heap memory are concerned, you are the one supposed to manage them. You have to allocate them, you have to deallocate them. So pointers is a very key thing you need to understand. So look at the diagram here. It will help us understand what pointer is. So in diagram below, we have a variable. We call it variable x equals 100. We know what that means already. We declared a variable called x. And we can use the shorthand method. If I use the shorthand, I'll just say x column equal 100. It's the same thing. Now, computer memories have addresses. So when you have a computer memory, when it stores data, it stores it somewhere. And there's an address for every memory location. Okay? So when you store something in a memory, if you want to pick it up, it's the address that you use to know where you stored it. So if you use the address to go, oh, it was set under address number 25, you go to number 25, pick up whatever is there, returned to you. So that's how memory is. They are segmented into different addresses. Okay, and you can store things there contiguously or depending on how if you declare an array, for example, that contiguous. The first one starts is a pointer, and it contiguously stores in up to wherever it ends. So over here is our memory. We have 1, 2, 3, 4, 5, 6, 7, 8, divided into 8 memory locations. And each location has an address. This one have 0x0201. This is a hexadecimal notation. Whenever you see 0x, it's hexadecimal. We have decimal, we have decimal, we have binary, we have hexadecimal. Hexadecimal is 0 to, when you count to 0 to 9, and you continue with A, B, C, D, up to F, 16. So that's hexadecimal. So the first one We just say variable x equals 100. Now see what happened. It goes to this particular memory address and stores 100 in it. That's it. So whenever you want to call x, it knows where x is. It goes here and gets it. But that's what we call a pointer. A pointer does not store a value. Rather, it stores an address. Let me take that again. Memories have addresses. You use the address to know where you're going to and pick the value in it. That's a regular thing. But for a pointer, pointer stores the address of a variable. Now see what happened. We declared x here and put 100 into x. It goes to memory 0 cross 0201 and put 100. That's fine. Okay. We now declared a variable called y, but we call this variable a pointer. Why is it how do we know it's a pointer? There's a star before the int. So it's an integer pointer. And look at equals to ampersand x. That ampersand means get me the address of x. And what is the address of x? Let's go back. Address of x is 0 cross 0201. Now what is stored in y? See 0 cross 0201. That's it. So a pointer, look, let's read it again. A pointer stores the memory address of other variables. Now, variable x stores a value called 100, which is actual value. But a pointer doesn't store the value, it stores the address of another variable. So when you declare a pointer y, you can now use it to save any address. In this case, we are using it to save x. We can say, hey, we want y to be a pointer to z variable, okay? In that case, we'll say this ampersand is what tells you, anytime you see ampersand anything, you are talking of address of that thing. And whenever you see star int, star anything, you are talking of pointer. That's how to know something is a pointer. So we say variable y is a pointer that points to an integer. So in this variable y, you cannot store string there. If you store string, it will throw error. You cannot store Boolean. 0 and 1, okay. But I know you cannot store string there, it will throw up error, okay? So that's what a pointer is. It shows where the memory is located. It shows where the memory is located. So in this case now, it tells us that A is stored at 0f201. So you go and look for this memory. That's what computer will do. It will now go and say, oh, here it is. It will now pick the value. It can also show the value stored at that memory location. Yes, that's what we call dereferencing. We'll see it in a bit, okay? And let's just go to that. I hope this is clear. A variable just stores your value, okay? But a pointer stores the address to a variable. So you can declare a pointer, just leave it, then later you now assign that pointer. You now assign an address to that pointer if you hold it. And you'll see how this is important when we go to manipulating values. All right. So pointer operators, we have the AND operator. It's called the address operator. It returns the address of a variable or a function. I explained that already. And we have the star operator. It's called the dereferencing operator. It returns the data at that address. So they are the opposites of each other, or not quite opposite. The thing is, AND operator will return an address of a variable for you, either a variable or function. The star operator will return the value. Let's go back to that. Let's take a look at this again. So when I say, if I do, okay, let's not get confusing. Next slide. Let's take this example. Variable x is an integer equals 1, right? Okay. And we have variable y, an integer. So we declare variable x here and initialize it immediately. That's what we have here. X is an integer that has the value 1. Then we have another one, variable y is an integer. We didn't assign anything to, we just declared a variable called y. Normal variable, but it holds an integer. Now see, we now declare variable z, star int. Star int means it stores, it's a pointer to an integer. We didn't assign it yet. We just declared a variable z. But z is not ordinary variable, it's a pointer, right? And it can only hold an integer. Sorry, it can only hold the address of an integer. Okay. So z is a pointer to an integer. That's what that means. Now when you say z equals ampersand x, now we are assigning z. In the first, we just declare without assigning anything. But in this case, we now say Z equals ampersand X. Now Z points to X. So if you go to Z, if you store the address of X, that's what this means. You say this Z as a pointer, we know it's already a pointer. Now go ahead and store the address of X. That's what it does here. Now look at what we call dereferencing. We now say Y is equal to the value at the address of Z. So if you go to Z, you store the address of X. And what's the value of X? It will return it to you. So when you have on your right-hand side, star anything, you are dereferencing. You are trying to get the value that is stored in that location. That's what this does actually, right? So in this case now, Y will be equal to 1. Let's see. Because Z stores the address of X, right? Now, when you dereference in X, what is the value stored at the address of X? It is 1. So in this case, Y is now 1. It's called dereferencing. Yeah, so we've seen two things. We've seen a pointer. We see ampersand, the two operators, the ampersand operator and the star operator. So the ampersand operator is used to get the address of a variable, not the value. Then dereferencing is used to get the value stored at that address. You will get this when you start doing some practice. It took me a while, but yeah, you'll get it too when you start doing some practice, but you'll meet them as we go on. So there's another way to declare a pointer, and it's using the new function. It creates a variable and returns a pointer to that variable. Variable is initialized to 0. Okay, I was saying this before. Yeah, it's initialized. So here we have PTR. It's just a variable. We call it PTR. We are trying to say it's a pointer. If you what PTR sound like a short for pointer. It doesn't mean it's just a variable, right? We now say equals to new int. Whenever you say this, it means PTR is a pointer. You just didn't put the star. Remember here, to declare a pointer here, we say variable Z star int. That's how we know it's a pointer. Another way to do this is to come and say, let's say Z equals new int. It's the same thing. All right. Now see, star pointer. Whenever you do star anything, you are dereferencing it. We now say the value of pointer, the value at this address is equal to 3. So wherever that address is, it will go there and put 3 in it. Star PTR means dereference this. That's the value. Whenever you dereference, you are getting the value stored at that address. So we're now saying, we're now assigning the value stored at address is equal to 3. So this is how you assign value to a pointer. So a pointer holds the address of a variable, right? So the pointer knows where that variable is. Now, when you now do dereference it, you are talking of the value. If it's from the left-hand side, it means you are assigning a value, okay? If star pointer is on the right-hand side, it means you are collecting the value. You are trying to access the value. So so it can be two ways. Star PTR, in this case, is in the left-hand side, which means we are assigning a value to the pointer. But when star PTR is on the right-hand side, let's say Z equals, let me go back to this one. See what we say, Y equals star Z. Now, star Z is on the right-hand side. We are trying to access the value. So when it's on the left-hand side, we are assigning value. When it's on the right-hand side, you are accessing the value. Just know this simple thing, then you will never have a problem with pointer. You must meet pointer in Go. In fact, Go and C, there are so many similarities, right? So many, as you will see. Okay, not all of you know about C, but I'm just saying they have so many similarities. Okay. So that's the new word. You can use new to also create a pointer. So I hope you understand what a pointer is. By the time you walk around with it, you know. The simple trick is know when you are assigning and when you are dereferencing. And I say that whenever star Z, the pointer is on the right-hand side, means you are accessing the value, you are dereferencing it, you are trying to take the value. And whenever it's on the right-hand side, you are trying to assign a value to it. That's the word, to assign a value to it. Okay, variable scope. We talk about variable a lot. So is a place in code where a variable can be accessed. So when you declare a variable, let's say X in your program, can you access X everywhere? That's the question. Let's say you're writing a program. We've done one now. We declared, we didn't declare a variable sort of in that program we wrote. We just put strings. Fine, but we can declare a variable. So when you declare a variable, how does it work? Can I access it from another function? Can I access it from another code block? That's what we're talking about. What is the scope of a variable? Look at the diagram there. I got the diagram from the addresses there. I can look it up. So you have the local scope. Local scope, look at, for example, you declare a variable, you can have a local scope where you can only access this variable within this place. Look at the global scope. I want to look at this too. The global scope means you can access it everywhere in that program. Okay, you have a built-in. This one now, like Go has many codes, variable that came from source with it. All right, you can access them from anywhere. If you run it, if you go, oh, okay, find out. Like if I say, okay, though we imported FMT here, we imported it. One good example would be window. In JavaScript, you have window dot something. Whatever you call window, you access it because it's global. No matter what, if you put window dot whatever function you do, it will work because window is kind of global to it. All right. So we're talking about variable scope. Let's look at this. By my left, we have variable X equals 7. Okay. Then we now have a function called F, function F, func F. And we say fmt.printf %d, x. That %d again is a placeholder. D means integer. Okay, it's a placeholder for integer. What are you going to store there? Remember what we did in one with the other one. After the quote, we put a comma. What are you going to store? Store x. So it will just print the value of x for you. That's what it does. So when you see %d means I want it to be an integer. If you see %x, S, for example, it means a string. %c means a character. So it's something you can look up. Now we have func G, and we say print X. Now, let me just tell you this. Func, when you say print X, what it does, it will look for X. This func F, this function, F function will look for X inside. It will not see an X. It will go outside of its group, its scope. It goes outside of here to look in the bigger part. And yeah, in the global part, there's X defined. So it will pick X and put here. All right. Now look at this one. We say func G, function G, say print X. If you look for X, there's no X within this. When I say block, the beginning and closing curly brace of function G is the block for it. So since there's no X defined inside this block, it will go out of its block. It cannot check F because F is a different block, but it can check the global space where it is. And if you look at here, you see X equals 7. So if you do this, both of them will print. Now let's see what happened in the right-hand side. In the right-hand side, we declare a function X, function F, and this side we have a variable X and assign 7 to it. fmt.print X here, this guy will just look for X within itself. First, that's the first thing you do. Locally, if you check, do I have X in the local variable here? You say yes. Okay, pick X and print it. Good. Now look at this one. It says function G, blah, then print X. It will now check, do I have X here? No. It will look outside. Now, F is a different block, so you can't go inside F. It will be looking at the global part of it, you know, the parent. In the parent, there's no X, so this one will throw error. Let's try it out. This one will throw error. Let's try it out and see. Yeah. Okay, come back to this code. What do we call this? Let me call it a name. Scope. Let's call it scope. So I make a new folder called scope. Under my Golang, I make a new folder called scope. I like naming things. Variable scope. I like making things obvious what they are. Okay. So under here, I can just create Scope.go. Again, we'll have to start. What's the first thing we do? Someone tell me. If you say package main, you got it right. So I say package main. And we import our function, the one we already know we are familiar with. We import in quotes FMT, the format function, right? And then we declare our func main. Func main for now doesn't take anything, and it has a block. So under this block, we want to give our scopes. So let me take a look at that again. Oops, what happened? Okay, we're here. Okay, let's take the second one. Let's say the second one. That's where the first one is obvious. You agree with me. Variable X is outside the global, so both of them can see X here. So let's take the second one and work on it. So we have a func F, right? And what does it do? Oh, we could just call func F. Sorry. So before I go to my main, 1 minute. So here I have my func F. Yeah, func F. Okay. So we declare variable X var X. It's an integer and is equal to 5, for example. Yeah. And we now say FMT dot capital P. In C language, print is small p, but in Go, P is capital P. That's what we're saying, just minor differences. So we want to print %D. So we want to print an integer %D. And what are we going to store into? We want to store X in it. Yeah, that's fine. All right. And we declare another function called func G, right? And here in the block, we just say FMT dot print F. %D, that's, we want an integer here, and give us X. Oh, print F is capital P, not small. C language is small p, but these guys. In fact, without running this program, we can see already, look what's going on here. This guy has, so let's see, it's an undeclared name, right? You see, undeclared name, we didn't even declare it. Because he knows he can't find it. In this case, he didn't complain, but we have it here, right? So without running the program, we could see what we are talking. So in terms of this G will not see this X inside F because it's a different block on its own and they're not related. Assuming FG is inside of F, yes, you can look up and see it, but as long as it's not inside of F, you will not see it. So I think that validates what we're trying to do. We can move on now, okay? But what happens if I move this line out of here? Control X, I cut this out. Let's say that. Now see, this func G has cleared up. No more error here. No more error. No more error here. Both of them can see. That's our first insight because it's a global. It's global to both of them. So that one. So when you are dealing, you have to know where your scope. You know, when you declare a variable, you know where the scope is acting, just so you don't get some weird results from your So here under main, nothing will happen if you run this program. You have to now implement it. So I could now say here, I could now say fmt dot print f. And what is it going to print? F. Yeah, f is a function. Let me see. Yeah, f is a function. So I have to put the function in it. No. 1 minute. I'm not sure why with F, and I'm calling G, for example. Okay, great. I still have an issue. Cannot use G value as type fog. String value. I'm not sure why I have this error here. Let me comment that code out. So it doesn't affect all this. I'll take a look at it again. Anyway, but we get what we're trying to say in terms of scoping. You know, we have the very different scopes, the global, you know, the local, and I think I have another slide on that. Let me pull it up. Okay, blocks. I think so a series of declaration and statement within a machine bracket is called a block. Let's look at this again. So func F, the whole of this between these opening and closing braces here is what we call a block. So the whole of this is a block. And here's another block. So you can have as many statements as inside it as possible. Well, in JavaScript, we did the for loop. Under the for loop, we say for blah, 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 so many statements, all of them forms a block. So hierarchy of implicit blocks. So we have the universal block. We just saw that. Okay, universal block. Go source. So everything in the source of Go is universal. You can access them, right? You have the package block. Everything on everything declared under a package can form a block for that package. So once you import that package, you can have access to everything inside that package. Then we have the file block. Okay, you can also import a file. So I can see you have the header file. Once you import it, you have access to all the scope within that file. Then we have if for switch case. We've seen all this if statement, for statement, the switch, all code inside the statement, you know, they're all blocks. So the clause in switch or select, yeah, under switch and select, any of those clauses you have there, it gets a block of its own. So you say if blah, 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 that thing is a block. Else, that else is a block of its own. So when you declare variable into each of them, you know that they are limited in that scope, except already their parents have that variable declared. Okay. So yeah. So lexical scoping. It's just a series of declaration and statement within a machine bracket, you know, including functions and definition. And the hierarchy of explicit blocks. I will have the, I'm just repeating this, sorry. I've gone through this already. I repeated this twice. Okay. So we're back to that one again. We have our B1, B2, B3. I explained this already. So where the B1 is the first one, the variable X is global to all of them. So func F has access to variable X and func G has access to variable X, okay? So we say BI, if BI is greater than or equal to B, no, we say BI is greater or equal to BJ if BJ is defined inside of BI. So in this case now, B1, okay, is greater than B2 and B3 because B2 and B3 are defined inside of B1. You can see that this variable X is global to all of them. So that's what we talk about scoping. So variable is accessed from block BJ if variable is declared in block BI and block BI is greater than or equal to BJ. All this grammar here is just what I explained before. right? In this case, variable x here is acceptable by function f and function g because it's greater than or equal to that, right? But in this case, this variable x is not assessed by g because they are not related. This is a block of its own. This and that block, and nothing relates to of them. Okay. So deallocating space, we're talking about pointers. So when a variable is no longer needed it should be deallocated. So memory space is made available when you deallocate. That is space. Memory space is made available. Okay, I can't edit here, can I? Yeah. Okay, great. So memory space is made available. Otherwise, we'll run out of memory eventually. Now think about every time you call a function, variable x, for function f, it will create a variable called x. You call it again, it creates a new variable. So each time you call this, it creates a new variable. Okay? Each time you call it, say you call it 1,000 times, it creates new variable f 1,000 times. Now, what happens if all these variables created are left in the memory like that, locked up? It means you get to a point, you have, let's say, 16 gigabytes of RAM, but you can't even use it anymore. Instead, you are out of memory. So what happened? It's called memory leakage, right? So that's why when you allocate a memory to something, you have to also deallocate it. And we know what happens in the interpreter already. To understand it, let's look at stack and heap. So stack is a dedicated to function calls. Is dedicated to function calls. Function memory calls. That's what it's dedicated to. So local variables are stored here, deallocated after a function call. So a stack, we have two types of memory when we're running a program. We have the stack memory and the heap memory. The difference is this: for a stack, whenever you create a function, for example, okay, it will create address memory locations where it can store. Let's say you have integer x, okay. In Go, for example, integer x, we use 4 bytes. Yes, we use 4 bytes to store one integer. So let's say you have 5 integers to store. If you do 4 times 5, that's 20 bytes. So it will reserve 20 bytes where it will store these things, right? In the function. The moment you leave that function and it's all done, it will deallocate it. But in a heap memory, heap is a persistent memory region. For a heap, in fact, that's where the actual thing, when you want to allocate a memory location by yourself using the malloc, that's what we call malloc, memory allocation. Whenever you call it, it will go to the heap, not a stack. Okay. The stack is for functions, function calls, plus, minus, as we are doing all those addition, subtraction, it's put in a stack. And they can dequeue all of them, right? But when you're trying to assess, let's say you are doing an array, you declare an array, okay? And so you want a memory space for that array. It goes to the heap and create the array for you. But in that heap, any memory there is persistent. Unlike stack, when you are done, it deallocates, you go away. But for the heap, it's persistent. So in C, for example, it's your duty. Whenever you install, you declare malloc, it creates that place for you. You have to go and deallocate. If you don't deallocate it, you have memory leak at some point. So that's the difference. The stack, just local variable x equals to this, it stores it there, okay? For heap, when you now request for memory, by yourself for, to reserve, let's say for an array, mostly an arrays, when you are doing an array, most time, yeah, you look at what kind of character are you storing. Let's say you are storing a char, CHR, char takes only 1 byte, and you want to store a name that is 32 characters long. It means you're going to have 32 times 1, which is 32 bytes, okay? But if the array is, let's say, 10, and it's going to store integers, so you have to have 4 times 10, which is 40 bytes. That's how you calculate it. But after you are done with the code, you have to go and free it up. But for manual deallocation, data on heap must be deallocated when it is being used. It's done being used, yeah. In most compiled languages like C, it is done manually, yeah. So look at this example, x equals malloc 32. It's saying x, reserve 32 bytes for x. So it requires 32 bytes to save whatever is in X. Okay. I say reserve it. Now, when you are done with your code, you have to say free X. If you don't say free X, this memory is tied down. It will never get freed up. So you might have memory and your computer is complaining there's no memory to use because you tied all this thing up. Here is error prone in the sense that you might make a mistake. I give you an instance. I was working on the C program sometime. It has to do with I declared malloc for some arrays, okay? And when I want to deallocate it, I wasn't so sure, right? So I think I deallocated it in the function itself, not in the main, right? So I now find out that when I run it, the values I'm getting, it gets correct to certain points, and I start getting gibberish. I'm like, why am I getting gibberish? So it happened that I freed up the memory too early. My program hasn't finished completed running, and I freed up the memory. So because I freed it up, it becomes available. It will now go and overwrite the previous data I have already because I freed it up. You say, hey, this is free now. So I might have A, B, C, D, E, F, G. You know, I have A, B, C, I have Z, X, Y, then C, D, blah, blah, blah. So it overrides the other part because I deallocated too early. And when I saw that, I have to correct that, take back the free into the main place, and the code run very well. So in this case, you manage it yourself. There will be error here and there. It's fast in the sense that you do it immediately. It's fast, okay? But what Go does is Go handles this. Okay, we know that natively interpreters handles memory for you. Let's say you are running Python or JavaScript. They handle your memory. You don't need to do anything about memory. They know when to, they time everything, see how it's done, you know when it's no more in use, they let it go. But if you're using a program like C, you have to manually manage that. But here now in Go, we are lucky. Go does what we call garbage collection. It manages those memory for you, even though it's a bit slower because it's not as fast as the one you did by yourself. If you can do it by yourself, fine. It's fast and simple. You finish, you know it's done. You just say release it immediately. So your memory available to use for another program rather than tying them down to a later time when Go comes to do its garbage collection. Okay, so it's hard to determine when a variable is no longer in use. I just gave a use case of my own program I ran, so I did sometime. And look at this program here. We say function foo is an integer. It's a pointer. This is like that star say function C is a pointer and it points to an integer. We now declare X, and assign 1 to it. That's X column equal 1 and return the address of X. That's a simple program. Now look at the other part. We now say function main. Okay, inside the main, we now say variable Y is a pointer and it makes reference to foo. Y equals foo. Now see what happens. If you come to the first function, you are done with the first function. You say, oh, I'm done. The first function foo is an integer. I return that, I'm done. And you go and deallocate. You have a problem because in the next function is also accessing foo, which means you cannot deallocate yet. This function has to finish, get done before you talk about deallocation. So you see, sometimes it's hard. You have to figure all this out. Oh, no. This address I save here, this memory location I did, this malloc I did this place is needed in so place, right? So you have to manually, track all these things to happen. That's why we say it's hard to determine when the variable is no longer in use, okay? But if you're using an interpreter, they do automatically for you. Don't worry about it. We are talking about compilers like C and Go. The upper hands Go has is that Go does its garbage by itself, unlike C, where you have to make sure you do it by yourself. So in interpreted languages, this is done by interpreter like Java Virtual Machine and Python interpreter. It keeps track of pointers and determines when a variable is no longer in use or has a reference to it. Then it deallocates it. So it's easy for programmers, but requires an interpreter. So if you're using an interpreter, no wahala, you don't have any issue with garbage collection. It does it automatically for you. But if you're using a compiler, which we know compiler are way better, in the sense they are faster. Remember, you could get compiled once, and you can run it 1,000 times, at great speed. Unlike interpreter, you have to go each time you want to run it. You start interpreting everything one by one, and get to the end of it. So Go garbage collection. No, garbage collection in Go. Go is a compiled language which enables garbage collection. So implementation is very fast. compiler determines, the compiler determines, missed an E here. It determines stack versus heap. So it knows when to go to stack, it knows when to go to heap. You don't need to worry about that. And garbage collection happens in the background. Like I say, it might be slow, but the trade-off is good. You know, if you check the trade-off, that you don't have to worry about it. Go will have to handle it for you. Well, it's a good trade-off. Okay, so having gone through all these things, there are certain things we have used so far. We just took them for granted, but I just want to, you know, talk about them. I've used them a lot. For example, comments. So comments are text for code understandability. It just helps your code more understandable. When you're writing the code and give certain comments, even you that wrote the code, you might come back the next week or the next month or even the next year, looking at your code. What am I trying to do here? You might not even remember. So if you that wrote the code can forget, how much more someone that don't even know what you wrote? So that's why we use comments certain areas. You just put some comment that shows what's going on. It's not like if I say I++, you put comment, you know, it's no brainer. I++, everyone knows that it's incremental. So you are trying to increment, so I don't need to put a comment there. But there are certain things you want to do, you just leave a comment, oh, this is that. So somebody within your code will know, okay, this is what we're trying to do. And for comments, compilers ignore comments. In C, for example, there's what we call the pre-processor. During the pre-processing part, it will pre-process it. Everything that has to do with comment, it will just strip them off. Only the codes. So compiler, comment is just for you, for your readability, for the next person to maintain your program, to understand what you're trying to do and know how they can fix things for you, right? So comments, they are not, compiler don't actually execute them. So how do you do a comment in Go? We have what we call the one-line comment. You start it with // Anything with // continue, that is a comment. I did that in the other program we did when I was trying to run func inside the main, right? And I had that little tick there. What did I do? I just put a // So it became a comment. It ignored it completely. Okay. You can also declare a variable. After declaring, you now put double comment and say what it is about. I can say pointer to something. So once you see // anything after that is a comment. So you can start from the beginning of this sentence. You can start somewhere after, not in between the dots. When you are done with your statement, at the end of it, you can put a comment. Then there's another way to do a comment. We call it a block comment. Remember when I was select code in the code editor, I'll select JavaScript code. After running it, we select all of them and say, make toggle comment block, toggle block comment, something like that. So when you put // and end with a *// that's a comment. So this is a multi-line. I have 10 lines of comment. Just start the first one with / and the star, then end it with a star and // okay? So that's how we do comments in Go. And just for the sake of comparison, this is also the way you do comment in C. That is similarity in C. That's how you do comments, both for single line and for multi-line, the same thing. What about printing? So to print anything in Go, you have to import the FMT package, the format package. It has some function. For example, the printf. We also saw the sprintf. I'll have the print line. These are different functions, okay? So it prints a string. That's what it does. So fmt.print high, it will print high for you. That's what it does. Okay. So for example, we say x column equal curly. So which means we assign curlies into x. That's the shorthand form, common with Go. I've not seen this in other language. I have not studied other language, so it might be other language I have it, but I know it's in Go. I have cause to use this shorthand, and it's kind of cool, right? Just x column equal that. That's it. You are done. You have declared and you are assigned. Good. So you say fmt.print high plus. Remember the concatenation thing. High plus. That plus here is a concatenation because it's string. It's not adding. When you say high plus something, whenever you are saying string plus anything, you are trying to concatenate. Remember what concatenate means? To join two strings. That's what concatenate is. So if you print this, you say high colors. That's what it prints. We know it will print without even going through it. So format strings are good for formatting. Conversion characters for each string. So I talked about placeholder before. When you see this percent something, it's a placeholder for some other source. So when you have %s, is a placeholder for X. In C, %P, is it %P, I think, is a placeholder for address. Yes, %P is a placeholder for address. %U, I think it's for, I'm not sure. Yeah, %LD for long double. You know, there are different placeholders. You can look them up as assignments. You see all these placeholders here. You put a placeholder, you put comma, then you can have two placeholders. Right? You can have %S and %D. What I'm trying to, in that case, you have to supply two parameters. See, after X, let's say Y. Don't mind the code, that this is wrong anyway. So the same %X, store X inside this place, and %D should be Y. That's how it's allocated. But %D must be an integer, and %S must be, so it means that X must be an integer. Sorry, X must be a string, and Y must be an integer. Or we can have %S, %S. It means X and Y are both, strings. So they're just placeholders you can use. Okay. What's the time? In the next 4 minutes, I should stop somewhere in the next 4 minutes. That should be 1.5 hours. Okay, so we've talked about integers a lot, but let's look at it in detail. So it's a generic integer declaration. This is how you do it. Variable X int. We declared an integer. Okay. So there are different lengths and sign. So we have int 8. Okay, we have int 16, int 32. So int 64, we're just talking about the number of bytes it's using to store the integer. So if you're trying to make your program lean, if you know that the integer you are doing, they are not so, integer, I think goes from 5, 7, I'm not sure. No, 3, 2, something, 32, something like that. That's the length of it. There's a code to find out maximum int or something like that. So a minimum int. So if you're using int 32, it will use more memory space than int 8 or int 16. So if you're designing your program, you know that this will not take more than so length, okay? You give it the particular length that you want just to make your code smaller. But come on, int 32 is a very common one, int 64. Then uint means unsigned int. What it means is that there's no negative sign in it. It starts from 0 up to, so it's longer. So that bit, this int 8, int 16, int 32, they can be positive and negative numbers. This int 32 can represent a negative number or a positive. So it goes from negative to positive. But when you have uint 32, it means unsigned, no sign on it. So you know when you don't have a sign on a number, it means positive. I say 2, 3, 4. We don't put sign because they're positive. But when it's not positive, we not put a sign. We say -3, -4. That is sign. So uint means unsigned. So it doesn't worry about the minus. That extra bit you used to figure out what the negative part is, it's added to your, store what you're looking from 0. So it helps you store more in it, unsigned int than int, which takes care of negative in addition to positive. Okay. And what kind of operation can we do on integer? We saw this before. We did it in JavaScript. We have the arithmetic where you can do the plus, the minus, the multiply, the divide, the modulus. We've seen all this. And the binary, the bit shift, either to the left or to the right, for shifting the binaries. Okay, we also have comparison, equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Please note that when we are doing less than or equal to, it's always either less than or greater than must come before the equal to. It's not, you don't do equal to or less than. It throws error. It has to be less than or equal to, or it has to be greater than or equal to, not the other way. So don't go and say equal to or less than, even though it's the same thing, right? But writing it out, always start with less than or equal to, or you say greater than or equal to. So note that. Then for Boolean, we have the and the or. I think we made use of this in our last class. Yes, we did, where we were doing for loop or so, and this or that with if statement. And the if statement, we are comparing it. So, and I said that in and, both condition must be true to be true. But in the or, you only need one condition to be true. Once one condition is true, everything is true. But in the and, all the conditions must be true. If you have 4 conditions, they must all be true. So get true. If one of them is false, you get false. Okay. So in Go, you have to be careful. When you declare a variable as a type, make sure that you use the same type to, to operate with it. What I'm trying to say here is that most binary operations need operand of the same type. So look at this. You say variable X is int 32. Not just, remember, if you just say int, it just takes the normal int we know, okay? The 4 bytes, right? So you can actually say variable X int 32 equals 4. Variable Y is int 16. Now, when you say X equals Y, it will fail because X and Y are not the same type. X is int 32 and Y is int 16. They are different. So to coerce them to work, you have to convert using the T operation. And how does it work? You can say that X equals int 32Y. Look here, we already said that Y here is int 16, right? So we're now converting that Y to 32. So if you just add the extra bits, that will turn it into a 32 bit. Instead of here, it's a 16-bit integer here. But here, it will now add the extra bit that will make it 32 bits. And when it does that, then it will work. So just know that if for any reason you are declaring different types of integer values, for example, right? Integer types, not value, integer types, right? You have to cast it. You have to coerce one of them, the other one, by using this type to convert it to that. And once you do that, then you're fine. My slide is still long. We're gonna stop here. Let me see the next slide. 1 minute. Okay, let me see my next slide. Okay, floating points. Yeah, I'll stop at floating point. So we also have the floating point. Floating point just means decimal. That's what floating point is. Integer are integral numbers, are whole numbers. Integer. Whenever you say integer, you're talking of 1, 2, 3, that's whole numbers. Not 2.5 is not an integer. It's a floating, it's a float. Okay, floating point. So floating points are decimals. Okay. And again, you can also have types. You can have float 16, you can have float 32. So float 16 has 6-digit precision. Float 32, 15-digit precision. So you have to be careful. In blockchain, addresses, most of the the balances, for example, they go for 0.0000000 something, something, something. So when you're designing, you have to choose the correct type, right? If you don't choose the correct type, there will be truncation. So you get wrong values because let's say you need 16 bits to represent the value, and you are using 6-digit. It means it will truncate every other thing, and your match will be wrong. So you have to choose your type very well to match whatever you are doing. So it's also expressed using decimal or scientific notation. For example, here we say variable X float 64 equals 123.45. This is a floating bet, 64 bits. You can also say 1.234 exponent 5. That's the mathematical notation for that. So I'm going to stop here. We'll look at more other things like the ASCII and the Unicode. These are some key concepts we need to understand. Then after that, we go into array proper. From array, we look at structs, and that will be the end of the course. That's in stage. That will be in part 3 of this course. So for the next set we are doing, right now the course is meant to archive on 1st January. but we're still waiting for our guys at Fitwork to come back from holiday. I've left all the necessary notification that has to be left, just so we know exactly when your assessment comes, get unlocked, to make sure you finish on time. And for people that haven't joined, you are part of this club, but you haven't signed up, there's still time. Please go sign up. Concentrate on the introduction to Bitcoin theory. Just concentrate on that and get done with it. You can view some of our videos and catch up with other things later on as we move into the second stage. Other than that, I'm saying happy holiday again, but we are meeting tomorrow again. I want to do a poll, but I'll ask our mentors, someone complained about timing of the classes, say 2 p.m. is not a good time. I'm not sure. I mean, if 8 p.m. works for people, I mean, it's good for me too. So I'll ask the mentors and see what feedback they get. If you guys want to do evening 8 p.m. class, it's fine with me. If you see the 2 p.m. class, it's still fine with me. I already devoted this time for this. So see you guys tomorrow, and thank you for being part of this class today. And again, tell your peers who haven't signed up, please go to Fitwork and sign up, finish up your course, and join your other people to the second phase. Thank you very much, and bye-bye. Stop sharing now.